In this lesson, we're going to look at how we could figure out a z-score given the area or probability. So to find a z-score given the area, we'll use the inverse norm in our calculator. So if you remember our previous lesson, if we look at these examples, we were given a z-score and we were solving for the area. Now we're going to be given the area and we want to know what the corresponding z-score is for that. So here's our first example. It says, what is the z-score if 63% of the data is below the curve? Now what does that mean? Well, I'm just going to draw here. You don't have to copy this part out. If I draw a curve, we know that 50% is this. But 50% is also this. So when we talk about 63%, well, are they talking about like more than 50%? Like maybe that's, I don't know, here, 63% of that? Or is it on the other side? 63%, because that's still the amount that's covered under there. So there's this caution here. It says, caution, the value returned is always the area to the left of a z-score. So that's very, very important. So when we say the area, that's always the area to the left. So if I were to draw this, right, we know that this is 50%, right? So a little bit further than 50%, we would anticipate that this would be, right, if this is a z-score of 0, that it would be somewhere around this region, right? So we can shade everything to the left. So that's what that means when we're doing this. So the area in this spot, that gives us an area of 0.63. Okay? But we want to know what is that z-score associated. We don't know what that is. That's a question mark right now. That's what we're trying to solve for. So how do we do this? Well, it says second vars 3. Then we put inverse norm, the area, and then mu sigma. So when I'm actually writing this out, what that would look like, we would find that and go inverse norm. My area is 0.63. My mean here, because this is z-score, is 0, and my standard deviation is each interval is counting up by 1. In my calculator, I would go to second, vars, same menu we were in before, and now you can see we've got our normal CDF, and right below that number 3 is my inverse norm. So I'm looking at 0.63, comma, 0, comma, 1. Close that off. So 0.33 is our z-score. So this would be a z-score of 0.33 is my final answer. So you can write z is equal to 0.33. And that's what it is. Now the hard part is recognizing when is it that you're solving for the z-score and when is it that you're solving for the area or the probability. So in these situations we're solving for the z-score. So that's nice because what we were wanting was to the left. Now B looks a little different. It says find the z-score P where P is greater than 0. So that means it's on the other side, right? Where P is greater than 0, so that the area between z equals 0 and z equals P is given where P is equal to 0.4710. So what exactly is this asking? Okay, so if we drew the diagram, I'm going to draw it a little bit smaller so I can write some stuff here. Here's my z-score of 0. That was this part. And a z-score of P where P is greater than 0. So we don't know where P is, but we know it's going to be a value greater than 0. And then they're saying the area between z equals 0 and z equals P, which would be this shaded area, the area between there is 0. I'm going to use another color here, 0.4710. So the area or probability under that curve, but specifically between 0 and P is that. Well, we don't want to know everything to the left of P. We just want to know that specific value. So what exactly am I saying here? Well, the calculator is going to tell you, if you just put in 0.47, it's going to assume that you're looking for all of this. Okay? which is kind of what we want, but not really, because all of that is more than 0.4710 in terms of our area. 0.470 is just the specific shaded part. So how do we get the calculator to read from negative E99 all the way through to P? Well, we know that the area under this part of the curve from 0 to P is 0.4710. Do we know the area from negative E99 to 0? Of course we do. We know, even though they don't give us that, that area is 0.5. So now that we know that this is 0.5 or 50%, and then the rest of it is 0.4710, 47.10%, we can tell the calculator, okay, find inverse norm from what? We've got two pieces. What we're going to have to do is add those pieces together. So we've got 0.4710 and 0.5. Adding those together, that would be 0.9710. We're going to put those together, so 0.9710. And then we have our mean of 0 and our standard deviation of 1. So punching that into your calculator, we've got 3, so 0.9719, comma, 0, comma, 1. And we get 1.91, I guess, if we were to round that, 1.91. So give us an answer of 1.91. So that means the z-score is 1.91. So this value p, instead of putting p, we can leave the p there, but we're getting an answer of 1.91. So it's almost to 2 standard deviations above the mean would give us that value. Okay, so this is a situation where we're given information, but because of the logistics of how our calculators work, we have to find the extra piece. In this case, that was that 50%, and telling the calculator that we need to know that piece as well. Okay, so we're given just from 0 to P. We tell the calculator, well, you know what, we need to know what the rest of this is in order to calculate. So we're going to figure out, okay, well, that's 50%. We put that in our calculators, adding it to the 0.4710 to get the z-score that's necessary. All right, the last example. C, it says find the z-scores so that the area given is between two scores, negative P and P. Given that the area is 0.6680 and it's between negative P and P. So what they're saying here, the fact that it's negative P and P is nice because that means they're equal distances away from each other. So if this is negative P and this is P, then the area we're looking for is this area here between negative P and P. And not the area we're looking for, the area is given, and we're finding the z-score. So we're looking for the z-score that's associated with this area, and they're saying that this area is 0.6680. So again, the calculator is going to start at negative E99. It just knows that. I need to start from here, and I'm going to look for this value, right? And once you know that value, we should know that value as well because they're the same. So how can I tell the calculator to start here and just go up to here when I'm not given any information about that shaded region? Right? This is this extra region that's not given to me. We all know that the total area under the whole curve is 1. We can find the area of the unshaded, in our case, the yellow region. If we do that, we would go 1 minus 0.6680. And we would get a remainder of 0.332. But what that's saying is that's this area and this area together. But we also know that those two areas are exactly the same. So in order to get just half of this, we would divide it by 2. We would get an answer of 0.166. So that's saying that this is 0.166 and this is 0.166. So now we can tell the calculator, we'll calculate inverse norm for 0.166. Find it for that area, and then it would go from here to here, and it could tell us what that negative p-value is. Well, if we know what negative p is, then we also will know what p is. So let's go ahead and try that. So inverse norm would be 0.166, comma 0, comma 1. Enter, and we can see it's negative 0.97. So negative 0.970. So that means negative p is negative 0.970 and p is 0.970. So those are our two z-scores. So therefore, the z-scores are negative 0.970 and 0.970. And that's it for today's lesson. So if we just do a quick recap, going back here, what we're doing here is we're given an area or given a probability, and we're finding the corresponding z-score. Remembering that the calculator always reads from the left. So for the first example, we were fine reading from the left. For the second example, we had to add 50% on so that we were getting everything to the right of 0. And for the third example, because it was between two values, we had to subtract from 1 the entire area under the curve, split it in half, and then we were able to read in from the left. Thanks for joining me today's lesson.